this video channel. In this video we are going to determine the detailed derivation of Compton shift, that is lambda 1 minus lambda 0 is equal to h upon m0c 1 minus cos theta, and also a derivation of Compton's wavelength, that is lambda c is equal to h upon m0. In this slide, let a photon of energy E0 and momentum P0 before collision of photon with the electron of rest mass m0. After collision, the scattered photon will have energy E1, momentum P1 and its wavelength lambda. After collision, the scattered electron goes in this direction. The scattered electron is also known as a recoil electron, and the scattered electron has energy K and momentum P. Now the scattered electron makes an angle phi with the incident photon, with the direction of incident photon, and scattered photon makes an angle theta with the direction of incident photon. Now the components, the momentum has component along x-axis and component along y-axis. So let us see component along x-axis. This is the momentum before collision, that is the P0, and after collision the x component, the component along x-axis are P1 cos theta plus P cos phi. Now this expression can be rearranged like this: P0 minus P1 cos theta is equal to P cos phi. This is equation 1. Now the component along y-axis, but the components are oppositely directed. So the P1 sin theta is directed in a downward direction, and P sin phi is directed in the upward direction. P1 sin theta minus P sin phi. This is equation number 2. Now from this equation it can be rearranged as P1 sin theta is equal to P sin phi. Now by squaring this equation on both sides, P0 minus P1 cos theta whole square is equal to P cos phi whole square. Now by squaring these two terms, P0 square plus P1 square cos square theta minus 2P1 P0 cos theta is equal to P square cos square phi. P1 square sin square theta is equal to P square sin square phi. Now by adding equation 3 and 4, in this equation there is P0 square plus P1 square cos square theta minus 2 P1 P0 cos theta plus P1 square sin square theta is equal to P square cos square phi plus P square sin square phi. Now from these two terms P1 square is taken common, so we obtain P0 square plus P1 square inside the bracket cos square theta, and from this term P1 is taken common, So plus sine square theta minus 2p1 p0 cos theta is equal to p square cos square phi p square sin square phi. So p square is taken common. Inside the bracket there remains cos square phi plus sin square phi. Now these two terms, uh, cos square theta plus sin square theta is equal to 1, and cos square phi plus sin square phi is equal to 1. So this equation becomes p square p0 square plus p1 square minus 2p1 p0 cos theta is equal to p square. This is equation number. From the law of conservation of energy, the energy of photon before collision was E0, and after collision the scattered photon has energy E1 plus scattered electron has energy K. From this equation can be rearranged as E0 minus E1 is equal to K, where for E0 we have to substitute C into P0, and for E1 we can substitute C into P1 is equal to K, where this P momentum is equal to H upon. Now if it is multiplied by nu, it will be H nu, and lambda is multiplied by nu, it will be lambda nu. So is equal to E, H nu is equal to E, and lambda nu is equal to C. So P is equal to E upon C, and lambda nu is equal to C. So P is equal to E upon C. So E is equal to P into C. Now from this equation C is taken common. So there remains P0 minus P1 is equal to K. Now this C is taken into denominator, then it becomes P0 minus P1 is equal to K upon C, equation number 6, and E is equal to PC. So consider the relation between total relativistic energy, momentum, and rest mass of electron after collision. So the electron has total energy K plus m0 c square bracket raised to 2, that is equal to p square c square plus m0 square c raised to 4. If we will expand this, then it becomes k square m0 square c raised to the power 4 plus 2 km0 c to the power 2 is equal to p square c square plus m0 square c to the power 4. Now k square upon c square plus 2k m0 is equal to p square. Now for this p square we have to substitute here p0 square plus p1 square minus 2p0 p1 cos theta, and for this k square upon c square we substitute p0 minus p1 bracket raised to 2 plus 2k p0 2k m0. Now from this we will square this bracket, and we will obtain p0 square plus p1 square minus 2p0 p1 plus 2k m0 is equal to p0 square plus p1 square minus 2p0 p1 cos theta. p0 square plus p1 square minus 2p0 p1 plus 2p0 minus p1 bracket close m0 c is equal to p0 square plus p1 square minus 2 p0 p1 cos theta. Now in this, from these two sides, this p0 square plus p1 square and p0 square plus p1 square from both sides will get cancelled, and we obtain minus 2p0 p1 plus 2p0 minus p1 m0 c is equal to minus 2p0 p1 cos theta. If we divide on both sides by 2, then we obtain minus p0 p1 p0 minus p1 m0 c is equal to minus p0 p1 cos theta. Now if we will take this term to the right side, then it becomes P0 P1 minus P0 P1 cos theta P0 P1 M0 C. So P0 P1 M0 C is equal to P0 P1 1 minus cos theta P0 P1 M0 C. M0 C is taken into the denominator of the second term, and P0 P1 is taken the denominator of this term. So finally we obtain 1 upon P1 minus 1 upon P0 is equal to 1 upon M0 C 1 minus cos theta. 1 upon P1 is equal to lambda 1 upon H minus lambda 0 upon H is equal to 1 upon M0 C 1 minus cos theta. Lambda 1 minus lambda 0 is equal to this H is taken here, H upon M0 C 1 minus cos theta. Now this lambda 1 minus lambda 0 is equal to delta lambda. This delta lambda is a Compton shift, and this H upon M0 C is equal to lambda C. This lambda C is a Compton's wavelength. If we substitute the values of H, M0 C, then we obtain the value of lambda C is 0.243 angstrom units of intensity versus wavelength. Now this is the incident wavelength of the incident photon, and here the scattering angle is 0. Now the scattering angle becomes 45 degree, then we obtain the scattering wavelength of the scattering photon as lambda 1. Now if we increase the scattering angle here to 90 degree, then we obtain the scattering wavelength here as lambda 1. Patient listening. See you again in the next video. Till then, bye bye, take care.